We've been talking about powers of 10, and with scientific notation, we'll be using powers of 10. And the reason why we use scientific notation are because different jobs require using various types of numbers, very large numbers, like for if you work for NASA and you're dealing with, space and the distance between the planets, or you're a researcher or a scientist and you're looking under a microscope, your number may be very, very small. So that is the purpose of using scientific notation. And I'm going to show you how to do it. I will post this page on Schoology for you so you can see this if you need it. You don't have this page. I just want to show you what it looks like. But I will post this in Schoology. So what I want you to do right now is just listen. And the benefits of watching my video is that you can always pause if I'm going too fast, or if you need to hear it again, you could rewind it. So here we go. So scientific notation, I want you to notice a couple of things. It is a number between the numbers 1 and 10. So this is a 6. So yes, that's between 1 and 10. You can only have a single digit on the left side of that decimal. So notice that you have a decimal here, and then of course you have a power of 10 here. Okay, that's all part of scientific notation, and you're multiplying. Okay, so down below, changing scientific notation to standard form. So scientific notation is a shorter way of writing a very large number. And what do you know about powers of 10? You know that that is 10 times 10 times 10 times 10, which makes a very large number. So you know that 1.56 is going to be a much larger number because you're multiplying it by 10 to the 4th power. So look at the rules here. You're going to move the first number's decimal right as many times as the exponent tells you to. So what does that mean? So the decimal is right here. So it's 1.56 times 10 to the 4th. This exponent here is going to tell you how many times you're going to move the decimal to the right. And how do I know it's to the right? Because it's positive. It's going to go to the right. It's going to create a larger number. So at that decimal, you're going to put your pencil where the decimal is, and you're going to move it 4 spaces to the right. So 1, 2, 3, 4. Now, this number is missing the zeros here, so I'm just going to fill the zeros in. When the decimal is at the end, you're going to write the number in standard form. Standard form is the number. So what is our new number? 15,600. So what does that mean? If you see a number that's written 1.56 times 10 to the 4th, that equals 15,600. So this is scientific notation. This is standard form. They're both the same number. Okay? Now, what if I want to change a standard form to a scientific notation? Again, standard form is the number. Scientific notation, we're using powers of 10. So in this case, I have a number. Here's my number. The question I always ask is, where is the decimal right now in that number? Well, the decimal is at the very end. You don't see it because you don't need it. But the decimal in this case is going to be important because you're going to move that decimal in the first number to make it a number between 1 and 10. And what that means is you're going to always move that decimal behind the very first number. Now, what you're going to do is drop any trailing zeros. Here are the trailing zeros. Now, how many places did I move the decimal? So the decimal was here. 1, 2, 3, 4, 5, 6. So I moved it 6 times. Guess what? That is my power of 10. You can drop the trailing zeros. So what do you have left? 2.407 times 10 to the 6th power. So this number, which was in standard form, now looks like this in scientific notation. So a couple of things to remember. In scientific notation, you're going to have a decimal. It's after the first digit. It can only be the digits 1 through 9. you're going to be multiplying by a power of 10. Okay? Now, let's go ahead to your notes. So this is page 18, scientific notation. So let's start off with the first part. Scientific notation is a way to represent very large numbers and very small numbers using only a few digits. Again, pause the video if I'm going too fast so you can catch up. It is written as a product of two factors. The first factor is a number greater than or equal to 1, but less than 10. So remember, you can only use single digits, so 1 through 9. The second factor is a negative or a positive power of 10. In that last slide, I did not show you negative powers of 10. I want to show you the positive first because I think that one is easier. All right, so you have very small numbers and you have very large numbers. So let's do our larger numbers first. Let's look at our positive numbers first. These are the very large numbers, our whole numbers. We're going to look at the right side of your paper, so make sure you're on the right side. Now, this box here, these numbers are written in scientific notation. How do you know that? Because you're multiplying a number using a decimal times a power of 10. So this is scientific notation. If you notice down here, those numbers are in standard form, the numbers. All right, so let's look at the first one. So notice that you have a 4. That can also be written as 4.0 times 10 to the 7th power. You could write it like that. So remember what we do. We take the number 4. The decimal is after the 4. You're going to move the decimal 7 places to the right. How do I know that? Because it's a positive 7. I know that 10 to the 7th power is a very large number, so my number is going to be bigger than 4. So the decimal is after the 4. I'm going to move the decimal 7 times, so just make 7 loops. 1, 2, 3, 4, 5, 6, 7. Okay? Now, what do you think you're going to fill in? Zeros. 2, 3, 4, 5, 6, 7. Okay? So what is our answer to that? So 4 times 10 to the 7th power. $40 million. You should have 40 million. All right, let's look at number 2. 3.1 times 10 to the 5th power. So we're going to write down 3.1. Our number is going to be bigger. How do I know? It's a positive exponent. So I'm going to move that decimal to the right 5 times. 1, 2, 3, 4, 5. Fill the rest in with zeros. 1, 2, 3, 4. Now, why didn't I fill in 5? Because the decimal was here. This was one jump. So what is my new number? 310,000. Right? 4.89 times 10 to the 8th. I know it's a large number because I'm multiplying by a power of 10. So 4.89. I'm going to move the decimal 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8. Fill the rest in with zeros. And you should have 489 million. There you go. That's easy, right? So you're just taking the number, moving the decimal. That's the easiest way to do it. You know that the number is going to be larger because you're multiplying by a power of 10, a positive power of 10. Now, down at the bottom, this is like the answers here down at the bottom. So we have to work backwards. So just know that this is the number in standard form. The decimal is behind each number. It's a whole number. So just go ahead and put an invisible decimal there. Now I want to change it to scientific notation. And what did we say in the beginning? We said that the decimal is going to go behind the first digit. So I'm going to count 1, 2, 3, 4, 5, 6, 7. Then you could drop the other zeros. So you could say 5 or 5.0 times 10. How many places did I move it? 7. So that's that number, 50 million, in scientific notation. So let's do the next one. Decimal is at the end. We're going to move it behind the 7. 1, 2, 3, 4, 5, 6, 7, 8. Now watch this one. This one is 7.08. You can drop the rest of the zeros, but you do need to include the 7.08. If there are zeros called trailing zeros at the end, you can certainly drop that. So what did we do? 7.08 times 10. We moved it 8 times, 10 to the 8th power. Okay, the last one. Count how many places. 1, 2, 3, 4, 5, 6. Now watch this one. 1.005. You can't drop the zeros until you get to the last 3. Times 10. How many times did we move the decimal? 6 times. So don't forget about this number 5 here. You can't drop it. You can drop the rest of the trailing zeros. All right, so how does that look? Not too bad, right? All right, now click on the next video for your very small numbers in scientific notation and standard form.